Hey, welcome to Accelerated Math. This is find inverses of functions. Now, an inverse of a function is it's kind of like the backwards version of it. If you think about the Celsius to Fahrenheit formula, which I can't quite remember right off the top of my head, but I think it's like 5 nines plus minus 32 or something like that. But there's an inverse that goes from Celsius to Fahrenheit, so it's just kind of reversing it. So you take a formula or a function that performs some calculation, and if you want to find the inverse, you just find out how to undo that. And let's take a look at it. And there's a nice little set of steps to go through on this, and here's what we're going to do is number one, we're going to replace replace f of x with y, and we're going to, once we do that, we're going to switch the x and y variables, just do a complete switch with them, and then we're going to solve for y, and I think that's it. Alright, and then oh yeah, I guess the fourth step is to formally then replace y with this notation. It's called the inverse function of x. All right, you may have seen on calculators where when we find sine, and then we have to do the inverse of it to find find an angle measure. This we use sine to find a side measure. If we use the inverse of it, it's this. The key looks like this, and they call that the inverse sine function. Well, this is an inverse function when it has that little exponent of -1 up there. All right, so let's put it in practice. See how it works with this one. So we're going to start by replacing f of x with y. So we're just going to put a y in there. Then we're going to switch the variables. So I'm going to take this function and I'm going to replace, I'm going to switch the variables. So I now have x equals 5y plus 1 over 4. Simple enough step. And then I'm going to solve it for y. Some of you are going to look at this and go, I don't really know how to start. Should I minus 1? Should I divide by 5? What should I do with this 4? Well, we're going to do something with this 4. We're going to multiply both sides by 4, because right now it's divide by 4. Well, the way to undo that is to multiply both sides by 4. So clearly this is 4x on this side. What happens over here? Well, think about this as like 4 over 1. It is 4 over 1. We're going to reduce, cross-reduce, what they call that, or cross canceling. They reduce to 1, and so I'm left with 4x on the left side, and I've got 5y plus 1. So that whole multiply both sides by 4 was just designed to get that 4 out of the denominator. Now we're going to continue. We got to, now I think you got to pick it up from here. You're like, oh yeah, I know this stuff. Minus 1 to both sides. Of course, 4x minus 1 is not 3x. They're not like terms, so the best you can do is write it 4x minus 1. Alright, and then we're left with 5y over here because we got rid of that 1. Now we can divide by 5, and what do we divide by 5? The whole thing. Okay, those 5's reduce to 1, or some teachers say cancel out, and we're left with 4x minus 1 over 5. And I think that's our answer on here, except for, almost forgot this last step, replace y with f, with the inverse function of x. So it's officially written like this, 4x minus 1 over 5. And there it is. Okay, I also want you to know that you might have to break this out. This 5 here is the denominator for both of those numerator terms, and so it could have been written like this, minus 1/5. It could have been written like that, and that might be real helpful if you have to graph it, because it's easy to identify the slope and the y-intercept, or the b-value. Okay, so just keep that in mind, that may you may have to find that useful in some other situations. All right, going to this one. F of x. Okay, so same deal. We're going to replace f of x with y. So it's now y equals, we're looking up here, y equals 5x squared. We're going to switch the variables. So x is equal to 5y squared. And now we're going to solve for y. And the first thing we're going to do here, we have to work order of operations backwards. I mean, some people might want to say, oh, there's a square root it. But wait a minute, let's get rid of this. We kind of have to work backwards on that order of operations. So we're going to divide both sides by 5. Y squared is equal to x over 5. Y squared equals x over 5. And how do we get rid of the square? Well, you said it earlier, you square root both sides. When you square root both sides like that, you get plus or minus the square root of x over 5. And then of course we're going to replace that. That's the inverse function of x is equal to, we're going to replace y with inverse function of x plus or minus square root of x over 5. Now, I want you to notice that there are two answers that look like that. This one, and it says the inverse function of x is a function. And then this one, and it says the inverse function of x is not a function. Alright, so here's the deal. The original function is 5 times x squared, and it looks something like this. It's because of that a value up front, it's a serious stretch. I didn't draw it quite to scale. But we know it's a quadratic. We know it's a positive a value, so it's going up. And we're going to look at an inverse function. You may have done something like this in class, where an inverse function is always a reflection over the y equals x line. Okay, so there's this line there, and an inverse function is always reflected over that line. And if you took a mirror, dropped a mirror right in on that parent function of y equals x, that parent function of the linear equation, you would see that this thing would reflect right over here like this. And so take my word for it, anything x squared, if it gets reflected, that's the inverse. And then I'm going to just check and see if this is a function. It's not a function. I did the vertical line test on it. I want you to notice that it's not to scale. But over here at 4, when x is equal to 4, when x is equal to 4, I get two options. I get positive 2, we'll call it, and negative 2. Those aren't the exact values, but my point is that it's not a function. It's inconsistent. It's failing this vertical line test, so we're looking for answer A here. This one was right until they said it was a function. So the inverse of a quadratic is never going to be a function. Keep that in mind in this worksheet. All right, last one. Y, they've already replaced it with y. So we got this, so we're going to swap out the variables. And there they are swapped out. Now, something new in here, we got that cube function, or to the third power. So we're just going to, we swap the variables. Now we're going to solve for y. So the first thing I'm going to do is plus 6 to both sides. Plus 6 to both sides. We got x plus 6 is equal to y plus 5 to the third power. Now how do we get rid of that third? If it was squared, if something was y plus 5 squared, the way you would have gotten rid of it would you would have square rooted it. Okay, so a square root takes out that square. They cancel each other out, so to speak. Well, very similar concept here. We're going to not square root it, but we're going to cube root it. Okay, and we have to cube root this side. Alright, so that's going to cancel it out, and you'll probably get a lot more next year in math on that cube root. But it cancels it out, so we got y plus 5 is equal to, I'm going to swap the order over here, put this over here, no particular reason, cube root of x plus 6. Now, can you tell me what the last thing is? Yeah, of course it's minus 5. What do you minus 5 from? Let's just tag it on the end. It's not under the square root. It's not under the cube root, I'm sorry. Cancels it out here, and so y equals the cube root of x plus 6 minus 5. That's going to be our answer. Alright, cube root of x plus 6 minus 5. There it is, C. Alright, that's it for this one.